So session is being recorded now. Okay, so we're talking about dependent and independent samples yesterday, and we defined independent samples if the sample selected from one population is not related to the sample selected from the second population, we call them independent, but if they are related, then we call them dependent, or they call them paired or matched samples. Like you match one item from one sample with another item in the second sample. These are dependent samples. Then we decided when testing the difference between two means in two dependent samples, your null and the alternative hypothesis have to be one of those pairs, either this or that, or the third one. If he asks you to test that the two means are different, it must be this. If he asks you to test that one mean is greater than the other, it will be that. If he asks you to test that one mean is smaller than the other, it will be this one. And then we performed yesterday a z-test for the difference between two population means when sigma 1 and sigma 2 are known. So when he gives you sigma 1 and sigma 2, you must do a two-sample z-test. We did two examples, and what I'm going to do, I'm going to do one more example, which is toward the end here. These are worked out examples, guys. I'm just gonna walk you through one of them right now, just to review what we did yesterday. So at the local college, 75 male students were randomly selected, and their mean monthly income was found to be $654 with a standard deviation of 168.70. Okay, I like to change this here. Population standard deviation. "65 female students were all randomly selected, and it was found that their mean monthly income was $612 with a population standard deviation of 121.50. The reason why I'm doing this because I meant to say population standard deviation so we can justify using the two-sample z-test. Tests that claim that male students have a higher monthly income than female students. So guys, he start talking about the males first. If he start talking about the males, you label them as number one. So males is mu1, and females must be the second one here, mu2. He wants you to check if the mean monthly income of males is higher than female students, so it must be this. We need to check that mu1 is greater than mu2. You can see, guys, this is HO and this is HA. Mu1 is greater than mu2, and then the null hypothesis will be mu1 less than or equal to mu2. Now, all we have to do is just to go to the calculator and input the values. You already seen the screenshots, but let me just demonstrate that to you guys. So you go to turn the calculator on, stat, tests, and it is a two-sample z-test. It's number 3, guys. All right. So input is summary, so stats. Sigma 1, you see he wants sigma 1 to begin with. And what was sigma 1? I said with a population standard deviation of 168.70. Then sigma 2, what was it with a standard 121.50. X1 bar is 654, and the other one was 612. And how many students? 75 male students, so that's a 75. Oops. Then X2 bar is 612. And how many female students? 65 female students. And we need to check that mu1 is greater than mu2. Make sure to select this one and press enter. To make it easier on you guys, I would have done this if I were you. Just split up the data into two sets, male, female, and put N1, which is 75, put X1 bar, which is 654, and put the value of sigma 1, which is 168.7. And then you do the same thing for female, but call it N2, 65 females, X2 bar, which is 612, and then sigma 2 was 121.50. It will be easier for you to input the data when you have them organized this way, guys. And now I'm ready to just run the test, calculate. So Z is 1.71 and the p-value is 0.0441 if you round to 4 decimal places. And you can see, guys, it's the same results right here. That's what we got, okay? So the p-value is about 0.044. And what is alpha? 0.01. You agree with me that the p-value is more than alpha here? So you're gonna fail to reject HO. Okay. If you fail to reject HO, what is your conclusion? Let me go back to my yellow sheet from yesterday. Watch, guys. Your claim is in HA and you fail to reject HO, you say, I cannot support the claim. There is not enough evidence to support the claim. I'm gonna be consistent, guys. I'm just gonna use this yellow sheet throughout. So there is not enough evidence at the 0.01 level of significance to support the claim. Now, what is the claim here? That male students have higher monthly income than female students. We cannot say that this is true. We cannot support this claim. So this is a review, guys, for section 8.1. I'm gonna go back now to section 8.2 and show you that the flow is gonna be very smooth. We're not gonna change much. And you will see that in a second. There you go. That is section 8.2. I'll write down 8.2 right here. There you go. So what is the difference between the two sections? Testing the difference between means, sigma 1 and sigma 2 unknown. So we don't know sigma 1, we don't know sigma 2. Just like in chapter 7, when we don't know sigma and we have S instead, we use a t-test. And here, guys, we're gonna use a 2-sample t-test. So instead of a t-test, we'll do a 2-sample t-test. Conditions of the test. Sigma 1 and sigma 2 are unknown. Samples are random. They are independent and the population are bell-shaped or the sample size is more than 30. What are the steps, guys? Exactly the same as before, same steps. Now, how do you state the hypothesis? It's exactly as in section 1 of chapter 8. You either could have this, that's one scenario, or you could have this one, that's the other scenario, or you could have that one, which is the third scenario. Do not make a fourth scenario, guys. These are the 3. You have to choose one of them always when you start a problem. Okay, let me just walk you through a problem and show you how to do this one. You notice here, guys, what I put S1 and S2. Once I put S1 and S2, forget about Z. You cannot use Z, it must be a T. So S1 S2 giving implies use t-test, which is a two-sample t-test here. The results of a statistics mathematics test for a random sample of students taught by two different teachers at the same school are shown below. Can you conclude that there is a difference in the mean math test score for the students of the two teachers? Use alpha equals 10%, assume the population are normally distributed, and that population variances are not equal. I'll tell you what that means in a second. Before I proceed, guys, I need your help to tell me which one of those three I'm gonna select here. Test the claim that there is a difference in the mean math test scores for the students of the two teachers. Which one would that be? First, second, or third? First, second, third. Can I have an input from 1, 2, 3 students, please? First, yes. It is the first because that is the different here, right there, okay? Actually, guys, if you know how to state the first step and you know which test to do, you're done. This is the claim. Since S1 and S2 are given instead of sigma 1, sigma 2, it is a two-sample t-test. Okay, let's run the test, show you how that works. So as you can see, I didn't need to do a big introduction of section 2. If we did 8.1, it's going to be the same. Watch. Stat, tests. It's not number 3, it's number 4, guys. Two-sample t-test. I don't have data, I have a summary, so I just do stats. X1 bar, it's 473. S1 is 39.7. N1 is 8. And watch, guys. X2 bar is 459. S2 is 24.5. And N2 is 18. What is the alternative hypothesis? Remember, this is the alternative hypothesis, not equal, so I selected that. Make sure to press enter. And now, please pay attention to this. He's asking you pooled, no, or yes. You cannot just put anything. So let me tell you what that means before I select it. You will select a pooled yes if he says the population variances are equal. And you will select a pooled no if he says the population variances are not equal. And what is it in our exercise? He says the population variances are assumed to be not equal. So not equal means pooled equals no.
I have a question.
Yes.
Are they always going to tell us if they're...
100%. Yes, they should. But if they don't, we assume it's a no, always. Statisticians assume it is a no. But they usually, when they want you to do the two-sample t-test, they're going to tell you. And look, this is a good hint for you. When you see this statement, you know that it's a two-sample t-test because this is the only program on the calculator that has the pool. So that's a good link to the test, actually, for you. Okay? So that's a no. Right here, pooled is no. And watch. So when they don't tell you this, you be suspicious that probably this is not a two-sample t-test. It is a two-sample z-test if they don't say that. Calculate. Okay, t is 0.922 and the p-value, oh, it's a huge, 3792. Here you go, guys. P-value is very big, which is more than alpha for sure. I don't even need to look what alpha is. It's huge. So you fail to reject HO. And if you guys fail to reject HO, I'll take you to my yellow sheet. If you didn't take a screenshot of it, do it now. Keep it handy. The claim is in HA. You fail to reject HO, you don't support the claim. You say, I don't have enough evidence to support the claim. there is not enough evidence at the 0.10 level of significance to support the claim. Sometimes the online homework asks you to select what the claim is, that there is a difference in the mean math test scores for the students of the two teachers. Okay. So this is it. Now the next one, next example, we're going to do one more example. Okay. What I like you to do, guys, I would like you to split up the information into two sets here. So I'm going to give you a minute to read it, and then we'll read it together and split up the information. Set 1 and set 2. Whatever he starts talking about first, label it as 1, and then the second one. So a manufacturer claims that the calling range in feet of its 2.4 gigahertz cordless phone is greater than that of its leading competitor. So we're going to label this one the manufacturer right here. And the other one is the competitor. You perform a study using 14 randomly selected phones from the manufacturer. Since we put it first, let's label it as 1. So N1 is 14. And what is N2 here? 16. 16 randomly selected similar phones from the competitor. The results from the manufacturer have a sample mean of 230. So that's X bar. But since there are two X bars, guys, you have to label them as 1 and 2. That's the reason why we have to use index 1 and 2. And the competitor is 216 feet. With a standard deviation of 26 feet from the first manufacturer. And the standard deviation from the second one is 32. And he wants you to check at alpha equals 0.05. Okay. He wants us to test whether the range from the manufacturer is higher than the range from the competitor. So I think you guys should agree with me that we need to test that mu1 is greater than mu2. That's what it says. It says the manufacturer claims that its calling range in feet is greater than the competitor. So mu1 is greater than mu2. Don't put x1 here. It's the mean. We're testing the mean. And this one will be that. Okay, look, he says population variances, guys, are equal. So when it comes to pooled now, you're going to select yes. Okay, let's run the test. On stat tests, 2 sample t-tests. It's number 4, guys, for this section. Stats. Okay, x1 bar is 230. S1 is 26. N1, how many? 14. X2 bar is 216. S2 is 32. And then N2 is 16. We keep going. We need mu1 to be bigger than mu2. Don't forget, this is the alternative side. And then one more step, guys, pooled. Yes, in this case. And then enter. Let me do a draw if you like here. It's a right tail test. So if there is a p-value, it will show on the right. Okay. So T is 1.303 and p-value is 0.1017. And I'm done with the calculator here, guys. It is bigger than alpha. Alpha is 0.05, so this is bigger. So decision is fail to reject 8 show. Oh, same decision in all exercises so far. And if you fail to reject the null hypothesis, guys, and you claim happen to be in 8A, you cannot support the claim. There is not enough evidence at the 0.05 level of significance to support the claim. And if you need to select what the claim is, that the calling range of the manufacturer 2.4 gigahertz cordless telephone is greater than that of its leading competitor. Okay, that's it, guys. That's a summary of section 8.2. So you perform a 2-sample t-test for the difference between two means mu1 and mu2 with independent samples with sigma 1 and sigma 2 are unknown. Now I'm just going to bring your attention to something you might notice if you go on YouTube to view some videos there pertaining to this. Like, just write this. And I'll show you that some books write this slightly different. They write it like that, and you guys tell me if you think that this is exactly the same. Would you guys agree that those two statements are exactly the same? If mu1 is greater than mu2, that means the difference is bigger than 0. Because if you subtract mu2 from this side and mu2 from that side, you will get mu1 minus mu2 greater than mu2 minus mu2, which is 0. So if you see something like that, guys, it's exactly the same as this, no change. You can move this. You know, in algebra, if you move one number to the other side, you just change its sign. And it's the same thing. If I remove mu2 to this sign, I just put minus mu2 and this will become 0. So these mean, they mean exactly the same thing. This is section 8.2. I'll do some more review exercises later. And now I'm going to go to section 8.4, guys, and then we'll revisit 8.3 at the very end. All right, so let's go to 8.4. 8.4 is going to be very straight forward, you will see. It's section 8.4, how to test the difference between two proportions. No means it's a proportions. Okay, what are the conditions of the test? The samples must be randomly selected. The samples must be independent. And the samples must be large enough so that you have N1 times P1 is greater than 5, N2 times Q2, N1 times Q1 is greater than 5, N2 times P2 greater than 5, and N2 Q2 is greater than 5. You remember, we checked those requirements in section 7.4. It's very much the same. If he doesn't ask you to check the requirement, guys, you just perform the test. And to perform the test, they are the same 5 steps. What I did, I just copied and pasted from the previous section and put them in here. What's going to be different, guys, instead of using mu1 and mu2, you're going to use P1 and put 2 when you test the proportion. And you have 3 scenarios, no other scenarios. Do not create a 4th scenario, guys. This is the first one. Or P1 greater than or equal to P2, P1 less than P2. If he asks you to test one proportion is smaller than the other, that would be it. And here's the next one, guys. And the test that we use here, it's called 2-sample proportion z-test. You see, it has the prop word in it. It's a 2-sample proportion z-test. Let's do an exercise and show you how that works. And please help me out with this one. In a study of 150 randomly selected occupants in passenger cars and 200 randomly selected occupants in pickup trucks. So we have 2 populations, guys. Passenger cars and pickup trucks. Since I have two sample size, guys, you have to label them as N1 and N2. N1 is 150 and N2 is 200. 86% of occupants in passenger cars and 74% of occupants in pickup trucks wear seatbelts. So there is 86%, I'm gonna write it here, and 74% there. At alpha equals 10% or 0.10. Can you reject the claim that the proportion of occupants who wear seatbelts is the same for passenger cars and pickup trucks? And you guys tell me which statement is going to be our null and alternative hypothesis. Can you reject the claim that the proportion of people who wear seatbelts is the same for pickup trucks and cars? Which one would it be, guys? First, second, or third?
First.
First, yes. And guys, for the first time today, the claim happened to be in the null hypothesis. Because he says the same means equal. Look, guys, here's another hint to know where the claim is. If he asks you, can you reject the claim, be sure that the claim is in HO, because we can never speak the language of supporting the claim if it is in HO. We just ask if we can reject it. If he asks you, can you support the claim, then he must have gave you the claim to be in the alternative hypothesis. So just tie, the word reject to the claim being in HO and the word support to the claim being in HA. So this is step 1, and it's a 2-proportion z-test, and let me show you how that works. Still have to do a little bit of tweaking, but I will pause and ask a few questions here. On stat tests. Okay, guys, you see it's number 6, 2-proportion z-test. So for 8.4, you only use number 6. Enter. Okay. He didn't give me X1 and X2. X1 is the number of successes, guys, from the first sample, and X2 is the number of successes from the second sample. He gave me probabilities. Any ideas? We need N and X, as you know, guys, when you do a proportion test. So how am I gonna find X1 and X2? I need an X1 and an X2. Any ideas? X1, how many out of the 150 wear seat belts in passenger cars? And X2, how many out of the 200 in pickup trucks wear? Yes, you are correct. I got students telling me you take the 86% and multiply by 150. That is exactly the case. And here it will be 0.74 times 200. So if he gives you percentages instead of the X values, make sure to take the percentage and multiply by the total here. So if you want a formula for X1, it is N1 P1 hat, and X2, it's N2 times P2 hat. Okay, great. You can do it on the calculator as well as we progress here. So X1 is going to be 0.86 times 150. $129. Warning, guys. If X1 turned out to be a decimal, you must round it to the nearest whole number. Don't forget that. Otherwise, the calculator will halt, will not proceed. X2, if you do 74% of 200, and N2 is 200, and we need to test that. We need the alternative hypothesis to be not equal. There we go. And let me hit calculate. And that's it. Z is 2.73 and p-value 0.0062. I hope by now, guys, you feel very comfortable with those p-values. And it's less than alpha for sure. So we reject HO. Okay. We reject HO, and the claim happened to be HO itself. So He's asking us, can we reject the claim? We'll tell him, yes, we can reject the claim. And let me show you the two scenarios, guys, that I haven't used much yet, right here. If the claim is in HO and you reject HO, you say there is enough evidence to reject the claim. So yes, we can reject the claim. There is enough evidence at the 10% level of significance to reject the claim. And what is the claim, guys? That the proportion of occupants who wear seatbelt is the same for passenger cars and pickup trucks. And be honest with you, actually, yeah, the proportion of people who wear seatbelts change from whether you're driving a big car or smaller cars. I see most of the time people in smaller cars wear seatbelts because they would be so worried if they get into a car accident. The car would not be able to handle, the accident, just properly. But if you're driving an F-150 or a big, just big car, you would think that you are safer than being in a smaller car. It doesn't mean that I'm saying that don't wear seat belts, but that's how it is. So the proportion is not going to be the same, and we end up rejecting that proportion that they are the same. Second question. I have another one from this section. Just 1 second. Let me get the second question, and then a medical research team conducted a study to test the effect of a cholesterol-reducing medication. At the end of the study, the researcher found that of the 4,700 selected subjects who took the medication, 301 died of heart disease. So it gives you N and X. So medication and no medication. So medication, let's call it N1, 4,700, and X1 are the number of successes, which is 357. Of the 4,300 randomly selected subjects who took placebo, so nothing, water, sugar pill, how many died? 301 here, sorry. And then X2, guys, he says is 357. Can you conclude that the death rate due to heart disease is lower for those who took the medication than the one who took the placebo? So if I project, guys, the three hypotheses, the three sets, which one would you choose? First, second, or third? He's asking us, can you prove that the proportion who took the medication is less than the one who took nothing? Which one would it be, guys? First, second, and third? Or third? Second. Yes, Julia, correct. This is the challenge for you guys to figure out, just the first step, because if you put the wrong claim to begin with, everything else is going to be tied to it and it's going to be wrong. We need to test that P1 is less than P2. You are absolutely correct. All right. And now two prop Z test. We're done. I'll go and perform the test for you. Let's put it under the lights. Okay, so stat. Two prop Z test number 2. Okay. What do we have here? X1, N1 is 47, X1 first, 301. N1, 4,700. X2 is 357. N2, 4,300. And we're testing the alternative hypothesis P1 less than P2. And let me do a draw here just to show you a picture. Oh. Okay, it says Z is negative 3.4546. And the p-value is 3e minus 4. Let me write them down. Well, you have to interpret the e minus 4. The e minus 4, guys, means you have to remove the decimal place 4 digits to the left. So it is actually 3.0 here. So if you move it 4 digits to the right, it will be, and that would be your p-value right here, which is less than alpha for sure. Every time you see an e, you can be assured that the p-value is very small, which is less than alpha. So we reject the null hypothesis. Oh, first time here we reject HO. Okay, we reject HO, and the claim is in HA. Well, I'll show you my yellow sheet one more time. Claim is in HA, reject HO, you support the claim. There is enough evidence to support the claim. At the what level of significance? Usually for medical studies, they require it to be at 1%. It is 1% here. To support the claim. What is the claim, guys, here? That death rate due to heart disease is lower for those who took the medication than for those who took the placebo. That means it is effective probably in lowering the death rate. Okay, so you perform a 2-sample proportion z-test for the difference between 2 proportions, P1 and P2. And the name of the test, again, guys, it's 2-prop z-test. It's number 6 under tests on your calculator. That concludes section 8.4. And the last section now, guys, I'm going to go to 8.3. I'm going to try to do a couple exercises in there. Any questions? We good? And now I'll go back to section 8.3. Just 1 second, I'm recording. Section 8.3 deals about testing the difference between means when the samples are dependent. In 8.1, in 8.2, and 8.4, the samples were independent. And now we're going to study the case where samples are dependent. I can assure you guys, definitely there will always be a question from dependent samples on the next test and on the final exam as well. This is how important, you know, this test. And that's why I left it to the end, because I want to use all the extra time that I have to go over this section. The conditions for the test. I'll go over this in a little bit. The samples must be random, always. The samples must be dependent, unlike independent in the other tests. And the populations must be normally distributed, or the sample size is 30 or more. If you have those 3 conditions met, guys, you can perform dependent samples test, which I'm going to show you the details in a second. I would like to show you the details through an example. So I'm going to turn the page over. And do this exercise with you. Again, samples are random, samples are dependent, population are normally distributed, or sample size is more than 30. Steps of the test, guys. You notice no difference from before. State HOHA, calculate the test statistic, calculate the p-value, make a decision to reject or fail to reject HO, and interpret your decision. Let's read the examples. And the first question I'll ask you if you agree that those samples are dependent. A shoe manufacturer claims that the athletes can increase their vertical jump heights using the manufacturer training shoes. The vertical jump heights of 8 randomly selected athletes are measured. After the athletes have used the training shoes for 8 months, their vertical jumps are measured again. So before they put the shoes on and after. Do you guys agree that this represents an example of dependent samples? It's the same person with the new shoes, without the new shoes. Athlete number 1, before he put on the new shoes and after he put on the new shoes. Number 2, number 3. When you see a table, guys, like this, it says all the new before and after, be assured that the samples are dependent and you have to do the math that I'm going to show you in order to test the hypothesis. Is there enough evidence to support the manufacturer claim? They claim that if the athlete wear their shoes, use their shoes, their vertical jump heights is going to go up. That's what they claim. So here's how we tested. We have those steps, and you guys need to follow those steps in order to get this done. You notice here, I put the difference between old and new D. So let's talk about athlete number 1. He went from 24 to 26. Do you think the shoes did work for this person, guys? Yes or no? I got a response here. Let me see. Okay, yes, I agree. Okay, what is the difference between 24 and 26? 24 minus 26 is -2. So if we get a negative difference, it means it works. Probably positive difference, it didn't work. 22 minus 25, guys, this person worked for him. It's a 3. He increased by 3, so the difference is -3. I'm doing 22 minus 25. Number 3, it didn't do any difference for him. Number 4 went from 28 to 29. That's a -1. Number 5, oh, number 5, it didn't work for him. He was doing 35 with the new shoes. He's doing 33, so the difference is 2. So I think, guys, you tend to agree with me. If the difference is negative, it's working. If the difference is positive, it's not working. For athlete number 6, it went from 32 to 34. That's good, -2. For athlete 7, oh, it made a big difference. It went up by 5. And for the last guy, it went up by 3. What's your overall impression, guys, from what we did so far? Do you think the athlete shoe, the manufacturer shoes do help in increasing the vertical jump height? Yes or no? Yeah, okay, you say yes. But the question is, prove it. Can't just say yes based on what I see. What about if the data is misleading you? So we need to perform a hypothesis test. And let me tell you how we're gonna perform this test. I'd like you guys to forget about this and that and focus only on the difference. So actually, when you do 2 dependent samples, it will turn out to be 1 sample only, which is the difference. In order for this to work, guys, would you guys agree with me that we want the difference to be negative? Yes or no? If it is working. Okay. Yes, we want the difference to be negative. So here's how we state the null and the alternative hypothesis. And then I'll go to the previous page and show you all the scenarios, guys. You put this simple, mu of the difference. Mu of the difference. We wanted that to be less than 0. This is the claim. The claim is the difference is negative. That means it's working. If it is positive, it's not working. And this is a greater than or equal to 0. So if I go back here, guys. When you test the difference, you have 3 scenarios. This is index here to say that the mean came from the difference here. Not equal to 0, equal to 0. This is first scenario. Second scenario, this is the one that we're using right now, less than 0. And the third scenario, and we chose this one for us because we noticed that if the difference is negative, that means it's working, and this is what they're claiming. So it's always against the number 0, guys, on the other side for section 8.3. Okay. Now we will put this data in L1 and we ignore those 2. That's it, we're done with it. Just take the difference and put it in L1. I've already done that probably. Let me show you. Stat edit. No, I didn't, so it's a different set. I'm just gonna put it in L2 here. So -2. You can do the same as I go over it. -3, 0, -1, 2, -2, -5, and then -3. I have my data in L2, guys. So you do, go to stat. It's a t-test. So for section 8.3, guys, it is a t-test, just testing one mean, which is the difference. So it's a t-test. Okay, that is a t-test. And your input should always be from data. It's always data. So t-test, I'll write it down once I'm done with the screen. And this number here should always be 0. Always, always you're testing against 0. And my list, I put it in L2, so I'm just gonna change this one to L2. And then you don't change the frequency, guys. Your alternative is less than. And if you want to hit calculate, there's calculate. So T is -2.33, and the p-value is 0.02618. Okay. So just let me double check on L2, just make sure I enter the right information. -2, -3, 0. Oops, sorry. 0, -1, 2, -2, -5, and -3. Yeah. Okay. So again, guys, let me repeat the test. Stat, tests, t-test. Scroll down to t-test. And then this is 0, always testing against 0. My list is in L2 frequency. This is it. And if you want, I can hit calculate here and write the results. -2.333. P-value is 0.0262. And that's it. Step 4, okay, what's alpha here? 0.10, so this is less than alpha. We reject HO because the p-value is less than alpha. Okay, your claim is in HA, guys, and you reject HO. If I show you my yellow sheet, it says, if the claim is in HA and you reject HO, you support the claim. Claim is in HA, you reject HO, there is enough evidence to support the claim. At the 10% level of significance to support the manufacturer claim. What is their claim? That athletes can increase their vertical jump heights using the manufacturer training shoes. So that's a good claim for them. We were able to support it. That means they do work if you invest in those shoes. So we perform a t-test to test the mean of the difference for population of paired data. Paired data, guys, means dependent samples. I'm going to do another one now. Okay, dependent samples. So that's why I left this question toward this section toward the end, because the treatment of the hypothesis is slightly different. Instead of working with this set and that set, you have to do the difference and test the difference against 0 always. So let's do another one and see if this will make more sense to you guys. It is right here. It's number 5. It's the last page of this handout. Physical education director claims by taking a special vitamin, a weightlifter can increase his strength. So a weightlifter, if they take a special vitamin, they claim that they can increase their strength. Okay, let's see. 8 athletes are selected and given a test of strength. Uses a standard bench press. After 2 weeks of regular training, supplemented with the vitamin, they are tested again. So before taking the vitamin and after taking the vitamin. That's what they mean before taking the vitamin. All right. Test the effectiveness of the vitamin regimen at alpha equal 0.05. Each value on these data represent the maximum number of pounds the athlete can bench press. Assume the variable is approximately normally distributed. So if you guys agree with me that these are the same athletes before they took the vitamin and after they took the vitamin. So if you want to label them, I'll label them number 1, athlete 2, athlete 3, 4, 5, 6, 7. Oh, just like in the previous question, 8 as well. So what you have to do, guys, you have to do the difference here. D. And let's see. Did it work for this person, guys? 210 went up to 219. What do you think? Yes or no? Okay, I'll check the response. 1 second. Yes, you're saying yes, I agree. Because this person went from 10 to 19. So the difference is going to be negative. 210 minus 219. 230 to 236, it's also worked. It's negative 6. Oh, this guy, no, the vitamin didn't work. 182 and went down to 179. The difference is 3, positive. Next one, 205, 204 went down. Didn't work. 262 to 270 went up. Difference is negative 8. 253 to 250 went down. Didn't work for this guy. 219 to 222, it did work. The difference is negative 3. And 216 to 216, no difference at all. Based on the results, guys, will you be able to tell someone that the vitamin is working or not working? What do you guys think? Without doing anything. You guys can make a conclusion based on what you see here. What would you think? I would say no, because I see it's working for some people, not working for the other. I don't know. We have to check it. We have to do a hypothesis test. Whereas in the previous one, most of them were negative, guys. It was easy to have a feel that it is working. But for this one, I cannot tell you it's working or not working. We have to perform the hypothesis test. Okay, I think, guys, you should agree with me now that if the difference is negative, it is working. If the difference is positive, it's not working. But the claim, it works. So we need to do the difference to be less than 0. That's the claim. And this is mu of d greater than or equal to 0. You put this data in L1 and run a t-test. Let's do it. Stat. Turn the calculator on. Stat. Edit. Okay, I think I have the data already right here in L1. There you go, guys. I put it there already. -9, -6, 3, 1, -8, 3, -3, 0. Stat, tests, t-test. Remember, section 8.3 is t-test. It's always a t-test. And it's always against 0, guys. But my list now this time is in L1. Frequency, we're testing that the mean is, the alternative hypothesis is less than 0, so I'll select that. Let me hit the draw. You can do a draw if you like. So T is negative 1.388, and the p-value is 1.1038. You can do a stat calc also if you like, t-tests. You can hit calculate. It's faster actually. Okay, let me write them down. P-value is 0.1038, which is more than alpha. And if it is more than alpha, guys, we fail to reject HO. And if you fail to reject HO and the claim is in HA, you say, I cannot support the claim. You see, we ended up not supporting the claim. There is not enough evidence at the 0.05 level of significance to support the physician, the physical education director claim. We're saying we cannot support it. And what is the claim? That by taking special vitamins, a weightlifter can increase his strength. We could not support the claim. Any questions, guys, about this one? So again, in section 8.3, guys, you test against 0. You find the difference and you ask yourself one question. Do I want the difference to be positive or negative in order to support the claim or go along with the claim? Whatever you come up with, that will be your claim, and you just put it in the proper hypothesis. Let me ask a question here, guys. What about if I give you the same question on the test next week and change a couple words there? Test the claim that taking the vitamin makes no difference in improving the bench press. What would be your null and the alternative hypothesis? So it says makes no difference. You're gonna get, you're just gonna do the same work, but your null and alternative hypotheses are going to change. So can a student tell me what would be the null and the alternative if it says test the claim that this makes no difference in improving bench press? Any ideas? Shouldn't be difficult, guys. Put this right here, and then you can tell me which one is it gonna be. Equal, yes, equal 0. That would be your claim right here. So if I ask you to test the claim that it does make no difference, it's equal 0. Let me just walk you over some languages and you know what. If I ask you to test the claim that it does make a difference, that will be not equal to 0. Ask you to test the claim that it does improve, we decided it's the less than 0. It doesn't improve, it's a greater than 0. But nobody would make a claim, nobody would claim that they're doing something that doesn't work. Nobody does that. Always when people make a claim, they're kind of try to prove the case. So it's always, they want that to work to their advantage. Like if I own an oil change place, I would never make a claim that my oil change, just takes more than 15 minutes. That's not a good claim for the business. You always make a claim that it takes less than 15 minutes to do an oil change. So this is section 8.3, guys. I have a few more examples that I'm gonna go over with before I wrap this up. And that should be it for section 8.3. All right, we did the first example. This is from section 8.1. Let me show you the other two examples right here. Let me see, I have yeah, I will go over questions if time permits, but let me just wrap this up. Definitely. Question 8.2. Let me show you question 8.2, guys. Okay, I would like to do this exercise with you. Let me see, we still have time. This is where you input data in L1 and L2. So I like, just to do this exercise, although I've done it here and showed you the details, but let's do this one and see how you can work with claim where you use data instead of summary stats. A sports analyst claims that the mean batting average for teams in the American League is not equal to the mean batting average for the teams in the National League. So you guys, he says is not equal. So you can see that mu1 not equal to mu2. This is a claim. These are not dependent samples, independent. This is American and this is national, two different teams. For dependent samples, this is the hint, guys. Look, you will see something like this. And it says here, section 8.3. This is dependent samples. Okay. The data listed below are from randomly selected teams in both leagues. At alpha equals 5%, test the sports analyst's claim. So they say that the mean batting average is not the same for the National and the American League. So we just put mu1 not equal to mu2, and that's the claim. What you have to do, guys, now you have to input this one in L1 and you put this one in L2. So let's do that and run the test. So I'll pause the recording for a second. So we have the data in L1 and L2. Now we go to stat, tests, to sample t-test. Data, you don't do stats here, because if you do stats, it's gonna ask you for a summary, guys. We don't have it. So just do data. Okay, lists, L1, L2, leave 1 alone. Where alternative hypothesis is mu1 is different from mu2, great. And pooled now, no or yes. Let's see what it says in the book, in the problem. Assume population variances are equal. So that means it's a yes. Please don't ignore this. It will change the formula. They get two different formulas, whether you do pooled or not pooled. And then hit calculate. And I got t negative 0.11, and the p-value is 0.988, which is a huge, guys. Right here. This is the p-value, which is more than alpha. So we fail to reject the null hypothesis. If you cannot reject the null hypothesis and the claim is in HA, you cannot support the claim. So you say there is not sufficient evidence to support the claim. And these are the screen shots here. Here's another question, guys. I'll leave it for you from section 8.3 with the screenshots. And there is one more question from 8.4. I also leave it for you to review. And then tomorrow when I review a little bit before I start chapter 9, I'm gonna go over the ones that I didn't do, 1, 2, 3, and 4 for chapter 8. So I'll just give you the chance, just to grasp the chapter, and tomorrow we'll do a little bit of